How are you all? Great. So I know I'm the last one you need to go through for the social and more beer. And so I'll keep it simple. I wanna do a lot of demos. So I'm gonna take that risk, and I already jumped the first hoop. And like John mentioned, I'm Vijay, Alagarraj. I'm a technical lead. I manage a lot of software developers in my group. I meet with the clients, I meet with internal people, and we develop applications and product that in our sales team, marketing team, or our customer delivery team needed to implement. Quantum Spatial is a full-service geospatial company from LiDAR collection to data collection to processing, analysis, and creating application hosting. So you won't have all that time, or I cannot speak to all that. And today I want to focus specific to electric transmission. So I saw some people talk about distribution. Is there any like a transmission related people or anybody from power? Okay, great. And also I saw a bunch of pipeline presentations. So this will be very close to those type of projects. So within Quantum, like I said, I want to focus specific to the transmission industry. So these are the topics I'm going to be talking about. Facility siting. I saw a presentation about solar wind siting, windmill siting, excuse me. So this is kind of similar. So we have a canned process, and we have a lot of an automated process to take a lot of information for to build the transmission line. So to start with, we consider all the natural environment. Bugs and Bunny says you don't need power, go build in your backyard. And the people like, I don't want in my backyard, you're affecting my view. So we need to consider all that options. So, and then you look at the built environment. So the easiest way to build is built along the road. And that's why you see a bunch of power lines on the highways and wherever there's a less development. And also you need to consider the engineering constraint. Just because I can find a place, your engineers come and say, absolutely, we cannot build there. So there's a bunch of, I would say, 100+ rules to goes into this siting process, and basically come up with an answer. That's what our clients are looking for. We not want to ask some questions, so we need to give them options. That is the answer, so they can take and run with it. So there's a lot of answers here. And this presentation, I'm not going to talk about the siting. That's why I went through this real quick. We have an hour presentation just on how we get to this answer. If you're interested in that, please contact me later. So my presentation is, okay, we create all this data, and then we put it in a printed map and give it to a client. That's not acceptable. So we create a bunch of map service for every step, and we give access to the client. So the client can use that information during their meeting with the clients, meeting with the public. They can interactively display this bunch of transmission line, center line options, and talk about how it's affecting the community, get their feedback. And also a lot of gentlemen here talked about do not dump everything on the map, and also give them some charts and spreadsheets. So we kind of following the same trend here. We're not just giving them 96 map services, hey, go have fun with it. So charts and map services helps. So this is one. And then also this presentation, I want to focus more on the user stories. So I'll be jumping between a lot of different projects and client. So I may be confusing, so Steve, please stop me if I'm too confusing. One of the user stories. So we start working with one huge electric transmission company, and for their distribution, they have very good small world data set. But transmission, absolutely, they're very minimum GIS data set, which you can relate to and somehow they decided to walk the line. So they are walking some 15,000 miles and creating data in a spreadsheet format. So this is before we are consulting with them. So by the time we are consulting with them, they already walked 4,000 miles. And then to make it even more fun, there were 4 different contractors working with 4 different templates of data. So how many all here like collects data or you get a field data to you and in a different format is a nightmare for you. So I can relate to the same thing. So we end up looking at, it's not just 4 templates. Within it depends on the inspector. So we had to deal with a bunch of different templates. So we started building a QC process, an automated process, instead of doing it manually. I know ArcGIS, one click, one spreadsheet is done, but the next spreadsheet is different. Put it all together. It's just a small user story I'm trying to tell. So we end up creating a bunch of walking survey data to create a feature class or geodatabase that they can use. This is one example. The second one, thanks for Dr. Srini to talk all about the LiDAR, so I don't have to cover that part. But this part is like, how many of you use PLS-CAD? Any engineers here? All right, some. And they use, they engineers in the design, they all live in the PLS-CAD world. And they take this LiDAR information and the point cloud information and they create a bunch of PLS-CAD modeling. And sometimes they don't even have real world coordinates in that. Oops. So we have a huge problem with that. But and then on top of that, their maintenance and operation team comes and say, I want all those attributes. When we track those down, they all live in PLS-CAD. So we built a process to export the PLS-CAD data to an XML. A bunch of you explained that also, and come up with a geodatabase through an automated process. Again, different versions of PLS-CAD, different versions of export. Those kills us, but we have a current version working for certain versions. But anyway, I focused on 3 slides creating data from 3 different groups or types, like through siting process, or through a LiDAR process, or through a walking survey. At the end of the day, you have a lot of data, and you need to make it more usable. So here comes the API. So we build applications to meet the customer needs. And based on the customer function and then the IT requirements, the API is always, what type of API is decided by those considerations. And some people are Microsoft old, shop, and we cannot do a flex there. And so there are considerations, so we had to consider, so we end up doing all different APIs. And most of those functions have all the basic GIS functionality. Instead of boring you with all this basic functions, I'm going to dive into each one of these and show very unique functionality. The very first one is fault indicator tool. I know in distribution system when there is a fault occurs, let's say 10 miles from a breaker, you know exactly where they are in small world. In a transmission side of it, it's not that easy. They are taking a guess, okay, it could be over there or over here. So we built a system to, instead of do it in the PowerPoint. So we built a little tool, and basically what happens here is they come and pick a line. That's this one big transmission line here. You can see it has a lot of branches, a lot of tabs in and out, and connecting to 7 different substations. So as soon as I punched in the line, it showed all the substation it's connected to. So I can now say there was a relay from this substation says there's a fault in 7 miles from there and also 9 miles from here. And when I click search, before this they are like assuming, okay, if it is 7 miles from there, is it over here, or is it in this branch, or is it in this branch? Or also I got input from the next substation. So they are sending the crew out and then taking an inspection and then also waiting for a confirmation, like to see which transmission switch they need to turn off to do their work. And that the longer the transmission lines are down, longer distribution is affected and you're losing money. So I'm going to turn the stations off so you can clearly see these dots. So what happened is, like within about 20 seconds, this is the 7 miles from this station. So it went here, it put a dot. Also, it put 7 miles in every branch. And it did the same from this substation over here. and then it's no brainer after that. It's the errors are on in that station. So you can now send your crew over to this area particularly and then start doing some work. Also, on top of that, you can save this information and say, hey, this is a calculated fault. Keep this in the database and see what's going on in the future. And also, you can put an actual fault. That's an actual fault right there. And you can compare between these two and tweak your relay. For next time the fault occurs, the fault location will be more precise. So this is one. And then I'm going to jump to the next. As we talked about GIS most of the time, integration. So of course, everybody talked about integrating with all kinds of systems. One of the quick thing I want to talk about is like integrating to a project management system, because everything else is covered so far in this morning, so far. And with this application, this is a hosted application, and you can, basically they go to a site and then they type, hey, I want to look at a project name, and I don't have to go through all this project information for you. But the cool part is like you click on a map, it takes you to a map and then show you that project. So now you have a project and a map, GIS and a project information tied up together in one place, and you got the other map services turned on, so you get the whole perspective how it's doing. Also, they did a good job in color coding, so you all can take a guess if it's color codes. Greens are on schedule, yellows are maybe behind schedule. Right on the borderline, and red is behind schedule. So they were overall doing a pretty good job. And then the same team, even for distribution or a gas pipeline, how many of you have a big time problem with maintaining the right-of-way documents, connecting to any information as you need? You need to go into a document management system, open a scanner, and see where the hell is the PDF. So, and they have the same problem here. And they hired a couple of interns to go through these documents and geocode and upload. And so that was a pretty cool project. So basically what they come here is like, look at these lines and then identify. So that's the exact easement. You can say that could be in a gas pipeline, a transmission line, and distribution. It's kind of the same model. So they can identify that and also see that information, all the information. So they have an option, so I'm not kind of logged in as an editor. As an editor, you can go edit online, but also you have option to upload documents and start linking. They don't have a robust document management system, so we end up creating one for them and managing it. But other clients prefer to still maintain theirs, so in that case, they don't need to upload. They just need to put the link to their document management system. So it's kind of, increasing their productivity that way. And a field user is calling saying this customer in the house behind us is complaining about some construction going on. He got information to this document with a click of a button. Another quick project I want to talk about is this, again, dashboard is a word overly used, dashboard 40. Like in the beginning, I mentioned about collecting LiDAR and a PLS scan. So this is very similar. Maybe I need to log in again. So we start with GIS all the time, and I like the keynote speaker of telling the story with some spreadsheet and chart go along with the map. So it's the same stuff. And we even take it further with some videos. So this application, what it's doing is it's like showing the users all the stuff, their projects or facilities on the map here. But also we have a canned process to create this PLSCAD 3D modeling. As you can see now, like all four views, all four modules are kind of interacting with each other. So what's happening here is this is a high def video that we collected while flying the right of way. And also the output of the PLS CAD 3D model is shown on the other side. At the same time, you're seeing the GIS feature class is kind of also moving the same time as the helicopter's moving to collect this data. And to make it even more complicated, we got some attributes here showing in and out. These attributes are nothing but like, hey, what is the span summary here? And can I go to the span directly? You can right click and go there. And if you want to investigate further, so you can pause anytime, or if this is too much for you, click plus button. All you want to do is like watch video. You don't want to do that through YouTube. Maybe this is fine. Or you are like a video is great. It is just eye candy stuff for me. I want to do more analysis. Video is not working out. Then you can go totally into the GIS viewer. This kind of the viewer you've been seeing so far. It has all these functionalities that you have seen so far. And through the LiDAR, our process, we detect all the vegetation, which is our growings, fallings, issue or not, so everything is displayed there. And let me click some imagery so you can see that this terrain is also really, really weird. Plus, once you're done with your analysis and you want to do with more reporting or your mean ground clearance chart or detection, all this information in one place. Again, we need to come up with a word, not just the dashboard maybe, but you have access to high-def video, 3D modeling, GIS interface, and reporting, kind of all in one place. Maybe I need to go back to the PowerPoint a little bit to make sure I covered everything. Sounds like it. So yeah, like I said before, all this live demo so far is fine, and I would say like I probably I'm gonna stop right now, and since I'm kind of done with the live demo, I could, if you don't stop me, I'm probably talking until 6 o'clock. So I'll do that for you. I'll stop now, and again, Q&A time, and I'm here to help.
Any questions? We have